In this video, you're going to find probability with the aid of a tree diagram. Let's consider the experiment of tossing two fair coins. The sample space can be represented using this possibility diagram. Now let's toss three fair coins. How do we represent the sample space? We commonly use tree diagrams. Let's consider the first coin. It'll give us a head or a tail. Now let's flip the second coin. Again, we are going to get either a head or a tail, regardless of what we get from the first coin. Lastly, we flip the third coin. What can we get? Still a head or a tail, regardless of the outcomes of the first two coins. So how many outcomes do we have altogether? We may get a head from the first coin, a head from the second coin, and a head from the third coin. We may get a head from the first coin, a head from the second coin, and a tail from the third coin. How about this outcome? Yes, it's a tail from the first coin, heads from the second and the third coin. Similarly, we can write down all other outcomes in this way. We can always use a tree diagram like this to represent an experiment involving two or more stages. Let's take a look at another example. Let's say that you're the 100th customer at a bubble tea shop and the shop is giving you a cup of free bubble tea. The bubble tea shop can give you any type of bubble tea available, and in deciding which bubble tea to give you, they're firstly going to randomly select the type of tea. The tea comes in two different types. It is either green tea or red tea. Then they are going to randomly pick the type of toppings. There are three different toppings that the bubble tea comes in. You can get red beans, black pearls, or white pearls. Suppose your favorite bubble tea is green tea with white pearls. Let's think about the probability of you getting your favorite bubble tea with the help of a tree diagram. One way to think about this is, what are the possible outcomes? And which are those match green tea with white pearls? There are two decisions to be made here. The first decision is the type of tea. You are going to get either green tea or red tea. The second decision is the type of toppings. If you got green tea, you're either going to get red beans, black pearls, or white pearls as the topping. Similarly, if you got red tea, you're either going to get red beans, black pearls, or white pearls as topping. The diagram shows the outcomes of a two-stage decision-making process. The result of each stage is shown at the end of a branch for that stage. For example, the two possible outcomes of the first stage are green tea and red tea. The outcome green tea is at the end of this branch. The outcome red tea is at the end of the other branch. For the second stage, the outcomes are again at the end of the branches. So how many possible outcomes are there? We can just count. Green tea with red beans, green tea with black pearls, green tea with white pearls, red tea with red beans, red tea with black pearls, red tea with white pearls. So there are 6 possible outcomes. This outcome right here is red tea with red beans, and this outcome over here is green tea with black pearls. Which is the one that we want? The green tea with white pearls. That's right over here. It's one of the 6 equally likely outcomes. So we have a probability of 1/6. Do you get it? Is this the only way that we can draw the tree diagram? We can think about the type of toppings as the first stage of the tree. Just like this. We can have either red beans, black pearls, or white pearls. For each of these 3 toppings, we're gonna get either green tea or red tea. This is another way of drawing a tree diagram to represent all the possible outcomes. What is this outcome right over here? This is green tea with red beans. This is red tea with black pearls. Which is the one we want to get? Green tea with white pearls. It's here. Once again, you can see that there are 6 equally likely outcomes. You may also present the tree diagram from left to right. Do you understand the tree diagram now? Can you think of other situations where the outcomes and probabilities can be represented by a tree diagram?